Assalamualaikum and hi, my name is Nur Ainina Hanani binti Muhammad Zabidi. Today I will present about infinite limits and limit at infinity. A limit in which function x increases or decreases without bound as the value of x approach an arbitrary number c is called an infinite limit. According to Theorem 1, we can conclude that limit x approach 0 function of x equals to positive infinity. This does not mean that we are regarding infinity as a number. It simply expresses the particular way in which the limit does not exist. In general, we write it symbolically like this. Let's take a look at the example. Limit as x approach 0 of the function of 1 over x. First, we need to check the limit at the left side and the right side. So let's start with the left side. What is 1 divided by negative 0.1? 1 divided by negative 0.1 is 10. As for negative 0.01, it is equal to negative 100. If we divide it by negative 0.001, that becomes negative 1000. The number gets larger and larger but with negative sign. Therefore, we can say that this approaches the negative infinity. Now, what about the right side of the limit? 1 over 0.1 is 10. 1 divided by 0.01 is 100. And 1 divided by 0.001 is 1000. As you can see, the number gets larger and larger. We can say that this approaches positive infinity. Generally speaking, whenever you have a small number in the denominator, basically 0 from the right side, it makes the value of the fraction large. So, this is equivalent to positive infinity. Keep in mind, if it exactly over 0, it becomes undefined. So, it really doesn't exist. But if it's close to 0, it will be very large. Whenever you have 1 over 0 from the left, it will become negative infinity. Now let's finish this question. Since these two limits from each side does not match, therefore the limit as x approaches 0 for 1 over x does not exist. Limit at infinity are used to describe the behavior of function as the independent variable increases or decreases without bound. If a function approaches a numerical value L in either of these situations, write limit as x approach infinity of function x equal to L. And function x is said to have a horizontal asymptote at y equal to L. Let's take a look at example. So what is the limit as x approach infinity of 1 over x? If we plug in number, whenever the denominator is large, you will get a small value and vice versa. For example, 1 divided by 10 is 0.1, 1 divided by 100 is 0.01, and 1 divided by 1000 is 0.001. Therefore, we can say that 1 over infinity, which is very large number, is going to be above 0. So, the limit as x approach infinity of 1 over x is 0. Now, what about the limit as x approach negative infinity of 1 over x? Basically, it will become 0. Let's graph this function. The graph of 1 over x looks like this. It has vertical asymptote at x equals 0 and horizontal asymptote at y equals 0. As you can see, as x approach positive infinity, you will get the horizontal asymptote which is y equals 0. As we follow the curve all the way to the right, it will get closer and closer to 0. This will also give you a horizontal asymptote which is y equal to 0. So, if limit x approach 0 from right side of 1 over x, it becomes positive infinity which move upward. While if limit x approach 0 from left side of 1 over x, it becomes negative infinity which move downward.